All right, in this lesson we're going to talk about dividing fractions using Cuisenaire rods. So before we do that, let's look at whole numbers. So if I have 8 and I want to divide it by 2, the question is how many times will 2 go into 8? So we can line up an 8 unit rod here and then start setting next to it the 2's, and we can say, oh, there are 1, 2, 3, 4 2's in 8. Likewise, we can take 8 and divide it by another number like 4 and say how many times will 4 go into 8? That's once, and then this right here is twice. There are 2 4's into 8. And so we're going to do the same thing here with Cuisenaire rods and fractions. So for instance, if I have 4 and I want to divide it by 1/2, I'm going to do the same thing. Now I don't have a Cuisenaire rod that represents 1/2, so what I'm going to do is first get rid of these numbers, and I'm going to let something represent 1 whole, something that's divisible by 2. Some of the questions I have in class are like, how do you know to use the light purple right here to represent 1 whole? I don't, and you could use something else so long as it's an even amount of units long and I've got enough units to represent 4 wholes here. So if I let this right here represent 1 whole, then 1/2 is going to be a red. See how that's half of 1 whole. But my question says not 1 whole divided by 1/2, it says 4 divided by 1/2. So I need 4 whole units here. So that's 1, there's 2, 3, 4. And I want to know what is 4 divided by 1/2. We said red is representing 1/2. So say, okay, there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 halves and 4 wholes. So 4 divided by 1/2 is going to give you 8. I think this is a good way to show it other than just using algorithms with students, because if you say, okay, you keep the 4, switch this to multiplication, flip this, you get a 2, 4 times 2 is 8. Yes, you could show it to them that way and they would probably learn it, but do they understand why when you take 4 and divide it by 1/2 you get 8? And so if you kind of use that and build off what they already know by like 8 divided by 2 is 4, kind of like we did at the beginning, then you can see, hey, 1/2 goes into 4 8 times. All right. Try another one. Try doing 5 divided by 1/3. Make sure as we go through these examples that you're pausing the video. Give it a try with using this virtual manipulative if you don't have a set of Cuisenaire rods. And then that way you get practice choosing what you're going to represent as 1 whole. So since I'm doing 5 divided by 1/3, I want something that I can take a third of. So I'm using this bright green block. I know I can take a third of that. And so I've got 5 of them. That's 1 whole. By the way, before here, let's back up a second. If that's 1 whole, what is 1/3 equal to? Because I'm going to take and divide that whole by a third. This, notice, represents a third because we can divide the whole up into 3 white pieces. So 1 white piece is a third. So I need 5 of these. There's 3 wholes, 4, and then 5. So I want to know if 1 white piece is a third, how many of these white pieces will fit in there. Well, we can drag them all out. It takes a while on the computer here. But you can just count them. We know that 1 white block is one of these gridded squares here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 divided by a third is equal to 15 of these white blocks, or 15. All right, try one more whole number divided by a fraction. Try 3 divided by a fourth. So pause the video, give that a try. So remember, we want one whole to be divisible by 4. So if this is my whole, then this right here is going to represent 3. And once again, I've got it so that the white blocks are equal to a fourth. Notice that's 1/4 of one whole there. So how many fourths will fit into 3? I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 of those fourths fitting into 3. So 3 divided by 1/4 is 12. Now, what if you chose something different, something else divisible by 4? Let's see, something, I think that's the 8 block, I believe it is. Now that's divisible by 4. So let's represent 3 right here. Just barely fits in there. Let's make sure it does. Okay, it does. So what is 1/4 of a brown here? It's going to be one of my red blocks. Just to prove it to you, I'll drag all 4 out. 2, 3, 4. So one red block is equal to 1/4 of a brown. So I'm letting one brown be a whole. I've got 3 holes here. How many fourths can I fit into 3 holes? So it should be the same answer we got earlier. There's 6, 7, 8, and then 9, 10, 11, and 12. And some of you may be saying, you know, I know that one whole is 4. I got 3 of them. Just say 3 times 4 is 12. And that's great thinking. And keep in mind, that's what we do in the algorithm. We say 3 divided by 1/4. You switch this to multiplication. You flip this, and you get 3 times 4, which is 12. But because of that, because of the visual here, you start to come up with that algorithm on your own without even somebody telling you what it is. And that's what we want, you know, is that better understanding of what these fractions mean and what it means when we divide them. So that's a whole number divided by a fraction. What I want to do next is take a fraction and divide it by a whole number. A little bit more tricky. So let's look at 1/2 divided by 3. Let's see if we can represent 1/2 divided by 3. So in this one I just chose bright green here because, well, mainly because it's divisible by 3, so it kind of, I feel like for some reason that will work out better for me. But if the bright green represents 1/2, then one whole is 2 bright greens. All right. So here's my half. This is 2 halves, which is 1. So 1 is the equivalent of which block here? The dark green. All right. So I'm going to get rid of these. Now keep in mind what I said the problem was. 1/2 divided by 3. Well, this is 1, not 3. And so I need to represent 3 here. There's 2. There's 3. So you say, well, that won't go into it an even amount of times. We can't quite do it like we did the last one. No, we can't. So my question is, what fraction of 3 does go into 1/2 here? So for instance, this is 3 blocks right here. I want to know what fraction of 3 is 3 blocks. So if you count them up, we have 1, 2, 3. Let's just put them out with green blocks here. How many green blocks make up 3? There's 4, 5, 6. There's 6 bright green blocks here that make up 3. So how much is one of those worth? It's going to be 1 out of 6 of those. So we say that 1/2 divided by 3 is equal to 1/6. Now think about what the algorithm for it is. We have 1/2 divided by 3 over 1. We made our 3 a fraction. And so we say keep the 1/2, change this thing to multiplication. I'm just going to move these things to a side and say, hey, there's a multiplication symbol. And then flip this last fraction here. And then we multiply it. 1 times 1 is 1, 2 times 3 is 6, we get 1/6. But here's our visual representation, and hopefully you're seeing like, hey, there are 6 halves in 3, so 1/2 is representing 1/6 of 3. All right. Try another one. Try doing 1/6 divided by 2. So for 1/6 to be divided by 2, once again, if we let, let's not use green. I feel like that's going to be, it's going to expand past our width here. Let's use red here. If this is 1/6, then 6 of these is equal to 1. 1, 2, 3, 4, 5. I need one more. Still might expand past it. There's 6, 7, 8, 9, 10, 11, and 12. So that's 1/6 of a whole. And then 12 of these give me 2. So the question is, what fraction is this going to be here? And what fraction of this? This represents 2, and it's lined up with 6. So this is 1/12 of 2. All right, there are 12 6 in the number 2.